Hello, Jaguar students. It's your friendly neighborhood math teacher, Mr. Allred. We're here with Unit 8, mini lesson number 3. Today we're going to raise powers to powers. We're talking about the power to a power rule. And by the end of the day today, you should be able to explain how to simplify expressions with powers. Just like the expression that you see there on your page, this guy right here. Okay, take a second to look at that. That's what we'll be working with today. We have one rule to talk about today that'll really help us out here in Unit 8. We're going to get started with the notes. Okay. If you read the top there, it says you can use what you learned about multiplying numbers with powers to find a shortcut for simplifying expressions with powers. Complete each statement by showing equivalent expressions. Let your final answer be written as a base raised to a single power in exponential form. Okay. The first one says 3 to the 6th squared. Okay, think about what exponents do. Exponents multiply numbers by themselves. Okay, exponents multiply numbers by themselves. That's something we talked about in the very first mini lesson in this unit. Okay, I'm going to star that. I think it's important. Okay, so if you look at 3 to the 6th squared, that's the same thing as 3 to the 6th times itself. 3 to the 6th. Which in truth is 3 times 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 3. Okay, if you count out all the 3s, you'd have 12 3s being multiplied by themselves. 3 to the 6th squared, same thing as 3 to the 12th. Okay, look at the second one. It says 5 to the 4th cubed. That's 5 to the 4th to the 3rd power. So 5 to the 4 times itself 3 times is the same thing as 5 to the 4th times 5 to the 4th times 5 to the 4th. We know from mini lesson 2 that when we have exponents with the same base being multiplied, we can add the exponents. That's the same thing as 5 to the 12th. Okay, 5 to the 4th to the 3rd, same thing as 5 to the 12th. If you had number 3, 2 to the 7th to the 4th, the same thing as 2 to the 7th times itself 4 times. 2 to the 7th times 2 to the 7th times 2 to the 7th times 2 to the 7th. So if you count out all the 2's being multiplied by each other, that's 2 to the 28th power, which I just thought would be interesting to show you. 2 to the 28th power is this humongous number, 268,435,456. That's not really that important. What's important is that this is the final base and exponent version of 2 to the 7th to the 4th power. A power being raised to a power simplifies like that. 4 to the 5th to the 5th. 4 to the 5th to the 5th would be the same thing as 4 to the 5th times itself 5 times. So 4 to the 5th times 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 4 to the 5th. So the total number of 4 to the 5th that you have, the total number of 4s would be 4 to the 25th power after you actually multiply all of them out. Okay, look at our answers there for the 1, 2, 3, and 4. What did you notice about the two exponents in the original expression as compared to the value of the exponent in the final expression? Think about that. Pause your video and talk to your partner. Okay, I kind of noticed that they were being grouped together, kind of like multiplication is. 3 to the 6th to the 2nd power was 2 groups of 3 to the 6th. So that's something to note. If you look at 1, 2, 3, and 4, we always took 5 to the 4th and grouped it 3 times, 4 to the 5th and grouped it 5 times. We were grouping those things together because we're multiplying it by itself. It's repeated multiplication. Okay, what operation would you use to go straight from the original 2 exponents to the final one? Talk about that with your partner for a second. The truth is that you can actually multiply the exponents to each other when you have a power raised to a power, an exponent raised to an exponent. So my rule, important rule here for you, is that when you want to simplify a power to a power, you can multiply the exponents. If you want to raise an exponent to an exponent, a simplified way to show that would be to multiply the 2 exponents together. And if you're still confused about that, you can talk to me when you come to my station. I hope the first 4 examples have helped. When you look at number 1 there on the bottom, it says 2 to the 2nd to the 3rd power. That's the same thing as 2 to the 2nd times 3. okay, you'd have 2 to the second times 2 to the second times 2 to the second. You can multiply 2 times 3 and get 6. That's the final version of that is 2 to the 6th, okay? If you wanted to simplify it, you could. 2 times 2 times 2 times 2 times 2 times 2 is 64. 2 to the 6th power is 64. When you look at one like number 2, you have a variable there, right? That would be the same thing as c to the 5th to the 4th would be the same thing as c to the 5th times c to the 5th times c to the 5th times c to the 5th. If you simplify that expression, you get c to the 20th. Oh, math is hard. 20th power. Okay, when you simplify that expression. It can get interesting in one like number 3. If you have two numbers inside parentheses and they're both raised to a power on the outside, this power does what I like to think about as the distributive property. It distributes to both things inside the parentheses. 3 times a squared with all of its squares is the same thing as 3 squared times a squared. That squared is going to simplify, distribute to both numbers inside those parentheses. 3 squared is 9 and a squared is a squared. I would simplify that as 9a squared. Okay. These last two examples I'll talk about, number 4 and number 5. If you look at number 4, you notice negative 5 squared. Number 5 says negative 5 squared. The only thing that's different is that in number 5, the negative 5 is in parentheses. This is a silly thing about math, and I'm going to try to demonstrate for you. I've shown some of you this. But number 4, because that negative sign is not inside parentheses right there, okay, that means that we are going to multiply 5 times 5 and keep it negative. Okay, 5 times 5 is 25. The negative sign out front makes it negative 25. Okay, when it is inside parentheses, that is when you're actually squaring negative 5. So you get negative 5 times negative 5, and a negative times a negative is always a positive. So please note that I got two different answers here for those two different math problems. If you still have a question about that, you're going to want to see me when you come to my station. Okay, the important thing here in this mini lesson is that when you want to raise a power to a power, you can multiply the exponents. That's the power to a power rule. And the rest of the problems that you'll see on the front and on the back are power to power problems. Okay, please enjoy your time here at the Allred Hotel. Okay, I hope you have a lovely time. And remember that of all my students I've ever taught, you are one of them. Thanks. Have a good day.